Now, we've seen how to break up different sorts of problems, different polynomials, and factor them out to where they came from when we multiplied initially. We're going to look at the use of a special pattern. There's more than one special pattern that comes up in factoring, but I'm going to focus on one and then just mention the others at the end so that you'll know where to look for them, that you can look for them in your text. The special pattern I want to look at is the difference of two squares pattern. Let's start by reviewing the product of the sum and difference of two terms. If we have x plus y times x minus y, and we FOIL that out, we will end up seeing that that comes out to x squared minus y squared. Now, when we factor this, we want to undo it. We want to go back the other direction, and we're going to call something that we see that comes at us as x squared minus y squared the difference of two squares. And you're just going to have to get in the habit of thinking, when I'm factoring, right away I'll write that as x plus y times x minus y. Flashcard fodder for you. And there's nothing for it but to look at examples. You have to recognize perfect squares. If you don't have perfect square numbers memorized, you will by the time you're done working through this material. Take something like x squared minus 4. You have to look at that and say, I see two things. These are my hot tips. I have two terms. They are subtracted, and one of them is obviously squared. So let me look at the other one and see if it's a perfect square. Well, this is x squared minus 2 squared. I have two perfect squares. I can write this as x plus 2 times x minus 2. It simply is recognizing the pattern, an x squared minus a y squared. The 2 is in the place of the y, and the x is in the place of the x in that original pattern. You would check this by FOIL. That's all there is to factoring by this method. Let's look at another example. You have something like 6y squared minus 54. Well, it doesn't leap out right away as being a perfect square, but I see two terms. They are subtracted, and one of them has the power 2. So we'll still go through our hierarchy looking for the greatest common factor, and there is one. 6 will go into both of these. So if I take out a 6, I have y squared minus 9. Now, I'm not going to factor by grouping. And I don't see a trinomial. But I do see a difference of squares. You can actually go in either order with choosing whether to look for a trinomial or the difference of squares pattern first. 9 is a perfect square. So this is 6 times y squared minus 3 squared. Well, I'm going to have y plus 3, y minus 3. And again, you can multiply that out to check it.